Hi, Mrs. Moss here. We've been talking about contour maps. Now we're going to finish going over some of the rules of contour maps. First, widely spaced contour lines equal a flat landscape. So if you see two contour lines on a map that are spread apart, like these indicated by the red arrows, this area in here is considered to be flat. Here's a picture of a flat landscape, or we also call it a gentle slope. Another picture of a flat landscape. This would have widely spread contour lines. The opposite is also true. Closely spaced contour lines indicate a steep slope or a cliff of some kind if it's this close together. Now on this map it looks like those contour lines are touching, but what you need to understand is they are not touching. They look like they're touching because the ink is very thick, but it's really not touching. Each line is a separate elevation. Here's the picture that I showed you before on the last video. This just shows where the steep slope would be in this map. And in real life, we have a steep slope or a steep gradient in this picture. Rocky Mountains, another area where we have a steep slope. This picture shows a landscape with both steep and gentle slopes. If you look here, we have a cliff, which would have closely spaced contour lines together, and we also have a flatter, gentle slope at the bottom. So the two combinations of spreading apart the contour lines and closing them together would be indicated on this contour map. So which side of the hill is the steepest on this slope, on this hill? West. The area is west, is close together, and so it's steep. Okay, contour depressions. Contour depressions are hills or divots in the landscape, and they're indicated by these little lines on the contour line. These are called hatcher marks, and it shows that you're going downward into that hole. So here's a picture of what a depression looks like. It's a hole. And here's a picture of the contour lines with the hatcher marks that we see on a contour map, and it's placed on the side view or the profile, so you can see it goes downward and dips down into a hole. We can add hatcher marks to basically any hill, and it would represent a hole or a depression. What would the contour interval be of this depression? 20. Just like we use the rules of contour lines for our regular elevation on a contour map, this time we would just go downward. We would start from the outside higher elevation at 60, and because we're going into a hole, the elevation would decrease. Here's a rule for a contour depression. It's important that you write this down. If the next line has a different slope, hatchered line next to a normal line, you keep the elevation the same, or you keep it once. If the following line also has hatcher marks, then you start to decrease the numbers. And I'm going to show you this as an example. This normal line here, the elevation is 50, and it's indicated on the map. The next line is a hatcher mark. So following our rules, this number is going to stay the same. And once this starts to go down into the hill, indicated by the other hatcher marks, we're going to start to decrease the elevation, so it'll go down to 40. If the next line has a different slope, hatcher line next to a normal line, again, you have to keep the elevation once. Okay, that's a very important rule. I said it twice, but you need to write it down and star it, okay? We're going to move on to maximum and minimum elevations. Maximum and minimum elevations are really when we're talking about a hilltop that we don't know the exact most amount or the highest peak. The maximum elevation of a hill is one number lower than what the next line would have been. So let's take this example at A. A, we don't know what the peak is. But we know that the last line that we see here is 40. This elevation is 40. We also know that the contour interval is 10. So we think to ourselves, well, what would the next line up be? It would be 50, but it's not written in. So we haven't gotten to 50 yet. So our maximum elevation of hill A would be 1 less than 50, or 49. So the possible maximum elevation at A in this instance would be 49. So what's the maximum elevation at X? Well, again, we look for our contour interval. Here, our contour interval is 20. We would next think to ourselves, what would the next contour line be of the highest elevation? Here, it would be 80. So we do 80 minus 1, and we have 79. 79 would be the most or highest possible elevation, or maximum elevation. What is the maximum elevation here? Well, we see that there is a contour interval of 20 meters. We see that the next highest is here's 200, here's 220. So we would then say, what it would be the next one? Well, it would be 240. So we subtract 1 from 240, we get 239. Our maximum elevation at this point would be 239. One more example. Now this time we're determining the minimum elevation of a hill. The minimum means the smallest number that it possibly could be. The minimum elevation of a hill is one number higher than the last 9 drawn. So instead of thinking ahead at the next contour line, we're going to use the highest elevation and just add 1 to it. So for this instance, we have the contour interval of 10. 10 is the highest elevation. We add 1 to that, and our minimum elevation would be 11. This brings us on to rivers. There's one more rule about contour maps that we need to be aware of when we're looking at them, and that's rivers. Generally, we look at rivers to determine the direction that the river is flowing, and there are 3 rules of remembering, 3 different possible ways we can tell. 1, rivers always flow from a higher elevation to a lower elevation, which kind of makes sense, right? Rivers can't flow up. They have to flow downhill. So we look at the numbers. We look at the hill and we determine where the highest point is, and then we know the direction of flow from there. The second rule is that rivers always flow into a larger body of water. So if you have a river and you have a lake or an ocean on your map, the river will flow into it. Third, we look at the contour lines, and this is a very interesting way of doing it. The contour lines bend upstream, which means they point in the opposite direction the river flows, okay? So when we look at, here we go. So the river flows in the opposite direction that the V points. So let's look at an example. I drew this in for us. If we look at this same map that we've been looking at, the contour lines, as they cross this river, they bend in this southeast direction. Everybody see that? Well, that tells us that the river is flowing northeast, okay? If you look, there's a couple of different ways we can look at this. We can look at the V's. It's flowing into the ocean, and it's also flowing from high elevation at 120 meters into the ocean at 0 meters. So there are 3 different ways that we look to determine the flow of a river and the direction that it's going. So which way is this river flowing? The compass tells you here that north is upward, okay? It's flowing northwest. So if you look at the V's, they are pointing southwest. I'm sorry, it's flowing southeast. The V's are pointing southeast, so it's flowing northwest. Excuse me, got a little tripped up on that one. So here are 4 different rivers. We need to determine which direction are these rivers flowing. And here we have no other indicator except for the way the contour lines are bending. Remember, they bend upstream. So the source of this river has got to be right here at the top of these hills. or at the base of these hills. It's a very confusing picture, right? But let's look at this red one. Which way is this river flowing? It's flowing northwest because the V's are bending southeast. How about the blue? Northeast because the V's are bending southwest. How about the green? The V's are bending northwest, so it's flowing southeast. And the yellow? Again, the V's are bending in the opposite direction. They're bending northeast, so it's flowing southwest. Here's another picture. We're going to be looking at that river right there. You can use the contour lines or you can use the elevation markers to determine the general direction in which this stream is flowing. High elevation, right there, low elevation. So this stream is flowing in the general southeast direction. Okay? This ends our rules of contour maps. We're going to work on profiles on a next video. So thank you very much for watching. Hope you got all of your notes down, and we'll see you tomorrow.